Hey guys, been a while since I've done a video, but seems like there's a popular request for my assistance all of a sudden at the end of the unit here, so just trying to make a couple quick videos explaining some of this so that while you're reviewing at home and before the test on Tuesday, thought maybe this could help you. So I'll go through as many as I can here, but starting with question 1, how do you test if a point is on a parabola? Well, first of all, the definition of a parabola. A parabola is a set of points. Let me get my pointer here. A set of points. So if I pick any point, like say, I draw this point right here, okay? I pick that point right there. I can measure the distance to a directrix. A directrix is the line kind of perpendicular or at the bottom of the bowl. This dark line is your directrix. That line is a special line that says if I measure the distance up to a point and then the distance from that same point over to the focus, those distances will be the same. If you look at, like, say I pick this point right here, the vertex. If I were to measure straight down, I would get some number. If I went straight to the focus, same thing. I go over here. It doesn't matter. A parabola is a set of points whose distance to the directrix, there it is, and the distance to the focus will always be equal. So that's our definition. So in our own words, how do you test if a point is on the parabola? Well, it's actually really simple. You just simply go in and you say, does the distance from the point that I'm testing match from straight to the directrix and then straight over to the focus? If it is, then the point lies on the graph, on the parabola. If it doesn't match, then the point is not on the parabola. Another way to do that, technically, if you have a way to write an equation, and we'll get to that later, just like any other, a circle, a straight line, any equation, if I want to know if a point is on the line, all I do is plug in the x and y value of the point that I'm checking. And if by plugging it in and I reduce both sides to a number, the number should match. So the left side might be 12, the right side must also be 12. If it's not matching, just like before in the measurements, then the point is not on the line. So that's question 1. I didn't really put much wording in there, but the answer key will be posted with written explanations here shortly. All right, there we go, 2.5 minutes, we're in. We've got question 2. So the parabola, given the focus coordinate and the line for the directrix, it does say write the equation and confirm the point is on the parabola. So the point is 19.8. So I'm going to go over here and I'm going to find 19, 8. I don't know if you can see that very well, but somewhere in that vicinity. Okay. So I'm just going to jump to, let's test or confirm that this point is on the line. We said in question 1, one way to do that is to measure the distance to the directrix. Well, I know that I'm up 8 because, you know, the line says, or the point says 19, 8. So I've gone 8 units up from the x-axis plus another 4 down to my directrix, because the directrix is the line y equals -4. So that is a total distance of 12. Distance to direct must equal the distance to focus. Okay, so the distance to the directrix is 12. Does that equal the distance to the focus? Well, the focus is also at a point 8 units up off the x-axis. So the distance up here is 8. So the focus and the point I'm testing are on the same horizontal line. I just need to know how far away they are. And we see that we are going from 19, 8, right? So there's 19 over here, and this was 7, 8. That distance is 12. So that is my way of confirming that that point is on the line. We'll get into, I'm going to skip the part where it says write the equation because we have other problems where we can test that. Anyways, also for time's sake, we're under 5 minutes. We're doing good. Question 3 says, looking at this chart right here, this graph, I want to know, Jeremy wants to know, he thinks negative 2, 2.25 is in fact the same distance from the directrix in the focus. We are told what the focus coordinate is. We are told what the directrix is. We even know that the point 3, 6 is on the parabola. So there's a few ways to go about this. We can use this information to create an equation, or we can just simply look at it and run the same test we did for number 2 with question 3. Jeremy says that the point is the same distance, blah, blah, blah. Adam says, there's not enough information. I'm going to skip this and move on. Well, all we need to do in order to tell the distance to prove Jeremy right, all we need to know is the point that the focus sits, the line for the directrix, and the point we're looking at. That's it. That's all we need to know. We have all of this information. So at this point, we know Adam's wrong. We know Adam is just lazy. He's that senior here, second semester, looking to just skip through problems. So Adam is wrong. There is enough information. That does not mean that Jeremy is right. It just simply means that Adam is wrong. We do have enough information. So here's what we're going to do. We are going to test that point. So I'm going to, maybe I'm going to change I'll change my color to red. I'm going to draw the point negative 2, 2 1/4. Negative 2, 2 1/4. Okay, so there we are. There's the point we're checking. From a visual inspection, it looks like it's there. We're going to check that by saying, okay, well, let's find the distance, right? So I'll have to erase it later, but distance to directrix and distance to the focus, right? We're checking those two things. Okay, well, the distance from the line of the directrix to my point I'm testing, I'm at 1, y equals 1 is my directrix, from 1 to 2 1/4. So my distance to directrix is 1.25, 1 1/4 units from the directrix to the point. Now the hard part is finding the distance. Change that color again to weird green color. We want to know that distance right there. We want to know how far that is. Is that also 1 1/4? Well, I'm going to do this. I'm going to create a triangle. I'm going to change my color back. All right. So here's my point, negative 2, 2 1/4, and here's my focus. Okay, so there's 3, and that's negative 2, 2.2. So my distance across I'm looking for. What I can do is say, hey, you know what? I can solve that. I can make a triangle and solve for the hypotenuse with Pythagorean's theorem. The distance from the negative 2, 2 1/4, so from here at negative 2, 2 1/4 to negative 1, 3, in the x direction I went from negative 2 to negative 1. That means I went a distance of 1 in the x-axis. To get from negative 2 from 2 1/4, to get from 2 1/4 up to 3, the y direction distance was just 3/4 of an inch. So I can do Pythagorean's theorem and say the square root of a squared plus b squared is equal to this question mark distance that I'm trying to solve. Well, if you plug that into a calculator, what you find is your answer is 1.25. So 1.25 is in fact equal to 1.25. So Jeremy is correct. Okay, we're approaching 10 minutes. 3 questions. Not too bad. Let me save that. We will continue on a couple more problems here in just a minute. But yeah, thanks for watching.